Good morning students. This is class 9th, subject science, chapter 8 motion. This is your lecture number 2. So students, in today's lecture, topics to be discussed are what is speed, what is average speed, velocity, average velocity, acceleration, uniform acceleration and non-uniform acceleration. So let's start one by one. First topic is speed. What is speed? Speed is defined as the distance traveled by an object in unit time. It is the distance traveled by an object in unit time. It is represented by small v. So what is the formula? Speed is equal to distance upon time. Distance we represent by small s, time we represent by small t. So this is the formula for calculating speed. Now if you are given distance and time, you can easily calculate what is speed. Okay. Now what is the SI unit of speed? Distance it is measured in meter, time it is measured in second. So it is meter per second. So what is the SI unit of speed? It is meter per second, or we can also write meter second inverse, one and the same thing. Now suppose it is given 36 km per hour. We are given 36 km per hour. So need to convert this kilometer per hour into meter per second. Because this is the SI unit, we need to convert in meter per second. So how to convert? 1 kilometer is 1000 meter and 1 hour it is 3600 seconds. So 36 kilometer is equal to 36 into 1000 meter divided by 3600 seconds. That will be equal to, when you will solve this, you will get 10 meter per second. So this is how you can calculate, you can convert any unit which is given in kilometer per hour into meter per second by multiplying by 1000 and divided by 3600. Are you clear? Okay. Now this speed, it is a scalar quantity. Why it is scalar quantity? Because it is a distance travel, and distance we discussed in the first lecture. It is scalar quantity. It has only magnitude, no direction. That's why speed is also a scalar quantity. Now your next topic is average speed. What is average speed, or how to calculate? Average speed, it is a ratio of total distance traveled by a moving object and the total time taken to cover that distance. So what is the formula? Average speed is equal to, it is a ratio means upon ratio of total distance and total time. So total distance divided by total time taken, that gives the average speed. So now you can calculate what is average speed. If you are given distance 1 and distance 2, you can add the total distance, and you are given time 1 and time 2, you can add total time, and the ratio of this will give you average speed. Now next is velocity. What is velocity? As I discussed, speed is distance upon time. So velocity is displacement upon time. Velocity is the displacement of a moving object per unit time. So velocity, it is also denoted by v. As we denote speed by v, velocity is also denoted by v. That is equal to displacement upon time. As in case of speed, it was distance upon time. Similarly, in case of velocity, it is displacement upon time. Now speed was scalar quantity because their distance was there. So what is velocity? It is a vector quantity or scalar quantity? It is a vector quantity. Why? Because it is displacement upon time, and displacement is a vector quantity that I discussed in the first lecture also. That is, there is magnitude as well as direction. Similarly, velocity is also a vector quantity. So are you clear about average speed and velocity? So basically what we can say that velocity, it is similar to speed, right? It is similar to speed. But what is the difference between the two? In case of velocity, direction of motion is specified. That is why we consider displacement. I repeat, velocity and speed are similar. The only difference is that speed is distance upon time and velocity is displacement upon time, and means the direction of motion, it is specified in case of velocity. So velocity is similar to speed, but direction of motion is specified in case of velocity. Clear? Okay. Now next is, what is average velocity? I discussed average speed, ratio of total distance and total time. Similarly, average velocity, it is a ratio of total displacement and total time taken to cover that displacement. So, if velocity of object moving along a straight line, it is uniformly changing, then average velocity, it is given by, it is the arithmetic mean of its initial velocity, that is denoted by u, and final velocity, that is denoted by v, for a given interval of time. What do you understand by that? Average speed was total distance upon total time, the ratio of these two. Similarly, average velocity is also the ratio of total displacement and total time. So, what is the formula? That is initial velocity plus final velocity divided by 2. That is the arithmetic mean. In maths, you calculate the arithmetic mean of the given data. Similarly, initial velocity plus final velocity divided by 2, that gives the average velocity. So, average velocity I have represented by AV for average and V for velocity. Average velocity is equal to initial velocity denoted by U plus final velocity denoted by V divided by 2. So, U plus V divided by 2, that is the formula for calculating average velocity. And in case of average speed, it was total distance upon total time. So, what we can infer from these two, speed and velocity? That speed is equal to or greater than velocity. Why? Speed is distance upon time and velocity is displacement upon time. Now distance, it is equal to or greater than displacement. I discussed the reason in the first lecture. Distance, it is equal to or greater than displacement. Similarly, speed that is distance upon time. So distance, that is speed it is equal to or greater than velocity. So are you clear about speed, velocity, average speed and average velocity? Now next topic is acceleration. What do you mean by acceleration? Acceleration, it is the rate of change of velocity of an object. It is the rate of change of velocity of an object. This acceleration, it is represented by small a. So acceleration is equal to change in velocity upon time. That is the formula for calculating acceleration. Rate means divided by time. So velocity, change in velocity divided by time. That is acceleration. And what is change in velocity? Final velocity minus initial velocity. Final velocity minus initial velocity. And final velocity we are represented by V and initial velocity we are represented by U. So V minus U upon T, that is acceleration. So in a given numerical, if you are given the value of V, U and T, you can easily calculate acceleration. Yes. Now what is the SI unit of acceleration? V or U, what is the SI unit? Velocity, what is the SI unit of velocity? Meter per second divided by time. Time, what is the unit of time? Second. So meter per second divided by second, it is meter per second square. Or we can also write in the another form, meter second inverse 2. Now I have a question. Tell me, acceleration is a scalar quantity or vector quantity? Acceleration is a vector quantity. Why? Because it has magnitude as well as direction. That's why acceleration is a vector quantity. And remember that initial velocity is represented by u and final velocity is represented by v, and we represent acceleration by a. So that is a is equal to v minus u upon t. This was about acceleration. Now, acceleration, it can be positive, it can be negative. In which case, acceleration is positive if direction of acceleration is same as that of direction of velocity. In that case, acceleration is positive. And when the direction of acceleration and direction of velocity, they are opposite, in that case, acceleration is negative. Okay. Now the next topic is what is uniform acceleration and non-uniform acceleration. I discussed what is uniform speed and non-uniform speed. Similarly, what is uniform acceleration and what is non-uniform acceleration. Uniform acceleration, if velocity of an object increases or decreases by equal amounts in equal intervals of time. Acceleration, what is the formula? Velocity upon time. Change in velocity upon time. So, if that velocity, it increases or decreases by equal amounts in equal intervals of time, that is uniform acceleration. We say the body is moving with uniform acceleration. But if that velocity, it changes, means it increases or decreases by unequal amounts in equal intervals of time. In that case, we say that object is moving with a non-uniform acceleration. So, are you clear about uniform and non-uniform acceleration? I repeat, in uniform acceleration, velocity, it increases or decreases by equal amounts in equal intervals of time. And in case of non-uniform acceleration, the velocity increases or decreases by unequal amounts in equal intervals of time. That is non-uniform acceleration. Let's take an example of uniform acceleration. The motion of a freely falling body. The motion of a freely falling body. That is the example of uniform acceleration. Why? Because the velocity, it is increasing or decreasing by equal amounts in equal intervals of time. Now, for non-uniform acceleration, if a car traveling along a straight line, if a car is traveling along a straight road, increases its speed by unequal amounts in equal intervals of time. That car is increasing its speeds by unequal amounts in equal intervals of time. That means the car is said to be moving with non-uniform acceleration. So, are you clear about uniform and non-uniform acceleration? Okay. Now, there is one more term. What is retardation? What is retardation? Retardation, we can say that it is negative acceleration. It is negative acceleration. That is retardation. Negative acceleration means the formula of acceleration, it is given by acceleration is v minus u upon t. Right? Acceleration, it is v minus u upon t. Now, if this initial velocity is greater, if this initial velocity is greater than final velocity, so acceleration will be positive or negative. If initial velocity is greater, then acceleration will be negative. If this final velocity, if this v is greater than u, so acceleration will be positive. Now, are you clear? Easily. So, what is retardation? It is negative acceleration. And what is negative acceleration? When the initial velocity, it is greater than final velocity, that acceleration, that is negative acceleration. So, this was about today's lecture. Now are you clear about speed, velocity, average speed, average velocity, uniform acceleration, non-uniform acceleration, positive acceleration and negative acceleration? So let's try some numericals. This is your first question. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other end and back along the same straight path. Find the average speed in average velocity of Usha. You need to calculate average speed and average velocity. You are given distance. You are given time. Now see distance, either it is 90 meter, 180 meter. It is given in SI unit, that is meter. But time, that is given in minute. So we need to convert this minute into seconds. So 1 minute is equal to how many seconds? 1 minute is equal to 60 seconds. So what is the formula of average speed? Average speed is total distance upon total time, right? It is total distance upon total time. Now what is the total distance? What is the total distance Usha has covered in swimming? The total distance she covered, that is 180 meter. 90 meter from this point to this point, then back from this point to this point. So total distance is 180 meter. Suppose this is point A and this is point B. So she starts from here, then reaches here, then back, she turns back and she reaches again to the original point. So this distance, it was given 90 meter. So total distance is 90 plus 90, 180 meter. So 180 meter, and what is the total time she took to cover that 180 meter? It is given 1 minute, and 1 minute is equal to how many seconds? It is equal to 60 seconds. So 180 divided by 60, that will be equal to 3 meter per second. So this is average speed of Usha. Now the question is, what is average velocity? What is average velocity? Average velocity, the formula is total displacement upon total time taken to cover that displacement. Now I told you that she is starting from this point, then moves here, then she turns back and returns to its original point A. So what is the total displacement? Initial position is this and final position is also this. So displacement is 0. Displacement is 0 because initial and final position, they both are same. So displacement is 0. And what is the total time taken? Same. 1 minute, that is 60 seconds. So 0 by 60, that is 0. So it is 0 meter per second. So average speed is 3 meter per second. Average velocity is 0 meter per second. You just need to substitute the values in the formulas. Now coming to second question. Your second question is, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second. Next 5 seconds. Now calculate acceleration of the bicycle in both the cases. See, you are given two cases. In case 1, his velocity is 6 meter per second and time is 30 seconds. Now in the second case, he is applying brake. The velocity, it changes from 6, earlier was 6, now final becomes 4 and the time 5 seconds. So calculate acceleration in both the cases. Now what is the formula of acceleration? V minus u upon t, that is final velocity minus initial velocity upon time taken. Now let's take case 1. Starting from a stationary position. Stationary means rest. The position was at rest, and at rest always initial velocity is 0. Keep this thing in mind. Whenever in any question it is given from a stationary position, from rest, it means initial velocity is 0. Now initial velocity represented by u, that is 0. Now final velocity is given 6 meter per second. And what is the time taken? 30 seconds. So now u is given, v is given, t is given. Now you can calculate acceleration. It is v minus u upon t. That will be 6 minus 0 upon 30. So the answer is 0.2 meter per second square. Do not forget to put the units. It is mandatory. Now let us consider case 2. In case 2, he says that he is applying brakes such that velocity comes down to 4. Means final is 4. V is 4 now. And what is initial? What was initial? It was 6. In the first case, 6 was final. Now in the second case, this 6 becomes initial. Now initial is 6, final is 4 and time is 5 seconds. Now you can calculate acceleration of the second case. It is u is 6 meter per second. V is 4 meter per second, that is final velocity. Time is given 5 seconds. And what is acceleration? V minus u upon t, final velocity minus initial velocity upon time. What is V? 4 minus what is u? 6 upon time 5. 4 minus 6 divided by 5. So the answer will come in negative, that is minus 0.4 meter per second square. So in the first case it was 0.2 meter per second square. And the second case it is minus 0.4 meter per second square. So are you clear how to calculate your numerical problems? Just you need to substitute the values. First of all, write down what is given in the question. It becomes very easy to solve the numericals. Write whatever is given in the question. Either it is u, v, t, distance, speed, velocity, whatever. Then write down the formula and just substitute the values. But keep one thing in mind, that convert in SI units. For example, if acceleration is given in kilometer per hour, you need to convert that acceleration in meter per second. If time is given in hour, convert that in seconds. If time is given minutes, say 2 minutes, so convert into seconds. So it will be 2 into 60. 2 into 60 seconds. So please convert into SI units. And after your question is done, do not forget to write the units. Okay, so this ends for today's lecture. Now, what is your homework? You can write down what is your homework. Question number 1, distinguish between speed and velocity. Question number 2, under what condition is the magnitude of average velocity equal to its average speed? Question number 3, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of spaceship from the ground station? Signal travels at the speed of flight, that is 3 into 10 raised to power 8 meter per second. So you are given time, you are given speed. Now you need to calculate distance. Now fourth question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration. It is very easy. Just substitute these values and keep one thing in mind. It is given in kilometer per hour. It is given in kilometer per hour. You need to convert. Now question number 5th. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour. Again, kilometer per hour is given. In 10 minutes, find acceleration. Find acceleration. Question number 6. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and average speed is 30 km per hour. What is the average speed? Now your last question. Question number 7. Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds. And then turns around and jogs 100 meter back to point C in another 1 minute. What are the Joseph's average speed and average velocity in jogging from A to B, second from A to C. So these are the 7 questions you will do today. Thank you, students.